Hi, Calculus 1 student. This is the end of section exercise on section 2.7. Okay? Without going any further for now, I just want to remind you that we did a very similar exercise in class. So you should certainly attempt this on your own using the technique we have done in class to solve this problem. And then what I would encourage you to do actually is if you think you got the correct answer, then jump straight to the end of the video so that you can see if you have the same graph as me. And wherever you see that there are discrepancies, then you can just like go back to see where you might have gone wrong. Okay, so if you didn't have attempted this exercise at all, please close this video and attempt the exercise. Otherwise, then here it is. So we want to sketch a rough graph of the derivative function of f, okay? And here I'm giving guidelines. I'm interested in what's happening to the derivative function when you have horizontal tangent line, vertical tangent line. I want to know, for example, when the derivative is positive versus negative. And occasionally, very occasionally, this is an example of it, I would like to have its exact value. Okay, the first thing you're going to do when you tackle these problems is to sketch a set of axes, okay? The y-axis, you make it match exactly like this, okay? So you just draw it right underneath. And you put the grid lines on the x-axis in the same positions, okay? So you're going to have this. This is maybe a little bit generous. I'm going to put it down a little bit. Okay, very good. This is all right. Okay, and this will be 5. Now try to line them up as much as you can. It's obviously easier to do in a notebook than on the board. So here. But after you have done a few, look how easier it is. Oh, my line is going down a little bit. Huh, that's hard. Easier with a ruler, hey? Okay. Perfect. All right, and then what we do is we use a ruler. I will use a ruler. You can use any kind of guideline. You can use also a pencil, right? As long as you have an object to follow the slopes that the tangent lines will take. So I will take a ruler. I think this is really good. So here, I can actually compute the slope pretty well because this is a straight line. The slope actually doesn't change between when we are moving along this straight line. So what I will do is here, I know this value, right? It's here. And at -5, so right here, I have a value that's like 2 less, right? So my rise over here is 2, and my run is 1. So as a result, in all between, like when x is below -4, the tangent line will have a slope of 2. So already, I will just have this 2 over here, and I will put an open circle and like this. Okay, now the open circle here, actually putting a closed circle is a very common trap. Because look, the slope of the tangent line at this point is not also 2 because you have to, the limit actually doesn't exist. The derivative from below is 2, but the derivative from above is actually 0. Okay, or actually the derivative from above is -infinity. Like you have to refer to the example that we have done for which the function was discontinuous. But here it's not important. The only thing we need to know is that since the function is not continuous in the first place, it cannot be differentiable. So that's why you put the open circle here. Then move on to the piece right here. And I put the guideline here to show you that the tangent line, you should read it as being horizontal, like as x is approaching -4 from above, the tangent line is getting more and more horizontal. And horizontal tangent lines mean that the derivative is 0. Well, in this case, it's approaching 0, but that's what it is. So we put a 0 here. Now, in this interval, the derivative here, this is the slope, right? The slope is getting more and more negative, and they actually blow down because the line is getting more and more vertical. So this means that at 2, the derivative has a vertical asymptote, and it goes like this. Now, right above -2, you should see that the tangent line is positive. And as x is approaching -2 from above, the tangent line is getting more and more positive. Right here, it's really, really positive and really big. So actually, as x is approaching -2 from above, the derivative is approaching positive infinity. So we put this over here. And without sketching anything else, let's first start with this. And then here, when x is equal to 0, you've got another horizontal tangent line. So very useful to put the point right away. So we know that from here, we have to reach 0. Okay, like this, let's say. Okay, what's happening after 0? Tangent lines like this. And the tangent line is getting more and more positive and bigger. It actually grows without bound. So the slope is approaching infinity again. So it goes like this. Yeah, this is good enough. Okay. Now, what's happening when x is approaching 2 from above? Okay, so now this is the slope. Okay, as you can see, the slope is positive. And as x is approaching 2 from above, it's getting more and more positive. It's getting larger and larger. So it's approaching here positive infinity. So again, let's not draw anything else here, just something like this, because we need to go to see what's going on here. So again, here, the derivative is positive. Notice that at 3, there's nothing special happening, okay? This is just a trap I like to put. Even if the graph is crossing 0, it doesn't mean anything particular about the derivative. But here, the derivative is positive, and as x is growing arbitrarily large, the tangent line is getting more and more horizontal, which means that its slope is actually approaching 0. So the slope approaching 0 really means that here we are doing something like this in the sense that y equals 0 is a horizontal asymptote of the derivative. All right, this is it. I hope this was helpful. See you in the next video.